Hey guys, Mrs. Ariaga here to talk about valence electrons and an element's reactivity. Chemical reactivity is basically an element's ability to react with other elements during a chemical reaction. An element's valence electrons are what determine whether that element will be totally reactive or totally inert. Let's start by looking at lithium. Lithium's atomic number is 3, which tells us that lithium has 3 protons as well as 3 electrons. But of those 3 electrons, how many of them are valence electrons? It would help to know what valence even means. Valence means outside. We know that lithium has 3 electrons, but how many of them are on the outside? How many of them are valence electrons? Yep, just 1. And it's this one valence electron that is responsible for making lithium totally reactive. A chemical reaction is really just an element's search for stability, and an element that's reactive is one that is very, very likely to experience a chemical reaction. In that search for stability, the element wants to become stable. And when I say stable, I don't mean like horses. I mean like happy, where the element is full and has everything that it needs. You may have seen an image like this before. Scientists sometimes draw atomic models this way to quickly see where an atom's electrons will be arranged. Electrons orbit the nucleus at breakneck speed, roughly organized into layers, sometimes called shells. The first shell can hold 2 electrons. It's the one closest to the nucleus. The second shell of an atom can hold up to 8, and the third can hold up to 8. Here's some examples. Hydrogen and helium are both very small atoms. Hydrogen has 1 electron, and helium has 2. For those 2 elements, their electrons fit on the first energy shell or electron shell. Helium has 2 electrons, and both of those electrons are considered valence electrons because they're both on its one and only shell. Therefore, they're on the outside. The next 8 elements, though, need an extra electron shell to hold their other electrons. Lithium has 3. Only one of those is on the valence shell or the outside shell, though. Beryllium has 4 electrons. 2 of them are on the first shell, and 2 of them are on the valence or outside shell. The pattern continues all the way through neon that has 10 electrons total. 2 go on the inside shell, the first shell, and the other 8 can fit on the second shell. After neon, the next element is sodium. It has 11 as an atomic number, therefore there are 11 protons and 11 electrons in sodium. 2 of those 11 fit on the first shell. That's this one. The next 8 can fit on the second shell. That's this one. That 11th electron, though, has to have its own shell because the other 2 shells are full. Out of sodium's 11 electrons, only 1 is a valence electron because it's the only one outside. Atoms that are unstable or unhappy are that way, and they're very likely to react because they are missing some of their valence electrons. Those missing valence electrons are what make them unstable. A stable atom is happy because its outside valence shell is full. Happy atoms have achieved their magic number on their valence shell. Either 2 if it's a little element like hydrogen or helium, or the next 8 need 8 valence electrons, and after that, 8 electrons is the third magic number. Our magic numbers are 2 and 8 or 8 in order for an element to be full. But if its element doesn't already have its magic number, how does it get there? The secret is in chemical reactions. Elements can react chemically with other elements to gain or lose electrons in order to achieve their magic number. They can share. Let's look at chlorine and sodium as a really good example. Chlorine's atomic number is 17, meaning that it has 17 protons in its nucleus as well as 17 electrons in the electron cloud. But of those 17, how many of them are valence electrons? Let's count the outside ring. 1 valence electron, 2, 3, 4, 5, 6, 7. Chlorine has 7 valence electrons. Now on to sodium. Sodium's atomic number is 11, meaning 11 protons in its nucleus and 11 electrons in the electron cloud. But only one of those electrons is a valence electron. You got it. 7 plus 1 gives them 8. When sodium and chlorine bond together, they share their outside electrons to achieve their magic number of 8, and they create sodium chloride. You call it salt. There is one column on the periodic table called the noble gases. The noble gases already have 8 valence electrons in their outside shell, or if you're talking about helium, that's this top one, it has 2, meaning its outside shell is full. It's got everything it needs, just like nobility of medieval times. They are happy the way they are and don't have to mess with the peasants on the rest of the periodic table. So there you have it. Valence electrons determine reactivity. Valence electrons will tell you all about an atom's chemical properties because of what it is likely to do based on those numbers of outside electrons.